Tangent and cotangent examples is where we're headed. Yesterday I kind of gave you the introduction of, okay, here's what tangent looks like, here's some of the features of tangent, here's cotangent, some of the features, right? And then I said, we'll look at examples tomorrow. So, we do kind of have to change our train of thought here. We definitely do. So, we'll work through it, and I'll try and give you some examples. And we might try and do all 4 examples to make sure since these are different. So number 1, 2 tangent of 6x plus pi minus 1. So if we go back to that same, okay, what am I graphing? We're graphing tangent, yes? And in terms of tangent, when I talk about the shape, I want to point out that tangent is an increasing graph. Okay? Now, I'm still going to do some of the same things. I'm still going to ask about the center line. What is my center line?
-1.
-1. And in fact, because I am really crazy forgetful on these, I went ahead and just put my -1 on my center line because I tend to that's an easy thing to forget here because we don't have the amplitude to do. So speaking of which, we don't have amplitude. It's either that A value is either a vertical stretch or a vertical flatten. What is my A value? 2. And so what's a 2 going to mean? Yeah, so there is a vertical stretch by a factor of 2. And again, it's not really anything we can label. It'll be more about how you draw the graph. So I'll show you a stretch and a flatten today, and you'll see the differences. We still need to talk about period. What about my period? Pi over 6. Because remember, sine and cosine were 2 pi divided by b. Tangent and cotangent are pi divided by b. So this is going to be pi divided by 6. And then, of course, we need to talk about any possible phase shift. What do we have in the way of a phase shift? C over b, opposite the sign. So negative pi over 6. Okay, we're good with all the information, yes? Now, I have to get my brain back in the groove on these too. As we start to label, our period is how much? Period is pi over 6. So my labeling, I'm going to do it a little bit differently, but I'm going to have to label my sixth. And every sixth is going to represent a cycle. So every sixth, you're going to see one of those tangent curves. And so what I'm going to do, and leave as much space as you want, I'm going to say, okay, we've got a pi over 6 here. I'm going to try and equally space it. And I really just wrote that as 2 pi over 6, which it is 2 pi over 6, right? But instead of 2 pi over 6, you could also call that pi over 3. Now, I've gone 2 to the right, which is really more than I even need. My shift is going to be to the left, isn't it? So I'm also going to put a equivalent pi over 6 to the left. Of course, I'm labeling it negative. Not sure how equal those all are, but I'm trying. And that's what I need you guys doing, is trying. So right now my graph is broken up into sixths. Now, there's going to be a cycle every sixth. We're also going to have the midpoints. We don't have to break these into fourths. We have to break them into halves. So I'm going to go through and put my tick marks in the middle. What are these tick marks, technically? What's a half of a sixth? A 12. And again, it's not that you have to label them. I'm just trying to help you guys make the connections. But that's pi over 12. Pi over 6 would be 2 pi over 12, right? So my next tick mark would technically be 3 pi over 12, if you will. Because then 2 pi over 6 is the same as 4 pi over 12. Now keep in mind 3 pi over 12 is actually what? Pi over 4. My 1 to the left would be negative pi over 12. Okay. I think we're ready to graph. Tangent. What do we start on with tangent? What's that rule say? You go back up top and look. The first thing you'll draw is the dot on the origin. So now, first thing we technically draw is the dot on the origin. Except, and this is one where I don't usually put the original. I go ahead and then shift it from here. So my dot's supposed to be on the origin, but then where does my shift take that dot? My shift is going to take the dot pi over 6 to the left. So my dot that should be on the origin is going to go pi over 6 to the left. Okay, now, that's my first dot. We're going to have dots or points once every cycle. How long is a cycle? Pi over 6. So every pi over 6, I'm going to put a point. So if my first point is at negative pi over 6, where's pi over 6 farther? Where's my next point going to be at? 0. So we actually ended up with a point there, didn't we? So what's happening is my shift ends up, the period ends up, we just end up on the same thing. And then that really would give us 2, but if I go one more, so we had negative pi over 6, 0, there'd be a point at pi over 6, right? So if I go once every 6th, I can even put a point at 2 pi over 6. Again, minimum 2 is your requirement. And I will always be looking for the one that positions it exactly, you know. So in this case, I'll definitely be looking for this one right here. In between your points are asymptotes. So once you have points, you're putting the asymptotes at the halfway point. So like here, negative pi over 6 and 0, there's an asymptote at negative pi over 12. So point, asymptote at pi over 12. Really, that would be enough. Again, this is a small one, so I have a couple extras here. I have an asymptote at 3 pi over 12. From here, we're ready to draw. Okay? It's a tangent curve, no reflection, so it is what I call an increasing curve. And if you go back and look, there was a vertical stretch, right? Not a flatten, a stretch. And I guess if it helps, I don't know, could you put another asymptote off to the left if it helps? You could. I mean, I don't have it marked there, but you could have one there. But a stretch just means, okay, as I go up and go through here, basically, I'm vertically going through the point on the x-axis. I'm not curving along the x-axis as much as I would with a flatten. Okay? There's one. Then go to the next set of asymptotes. There's another. That right there would be your minimum requirement. Okay? Since I have these other dots and points, or these other points and asymptotes, I can put them on. Okay. Questions there? You have to think a little differently, don't you? Ready to try number 2? Number 2, negative 1/2 cotangent x over 2 minus pi over 4 plus 3. Can we just make everything fancy here and difficult? Okay. 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 What, are we unhappy I'm back in the classroom to finish teaching?
No.
Okay, what do we have here? Did you guys do any of this without me? Probably not. Maybe.
I got a vertical shrink.
Okay, well, there's a start.
I got a center line.
Okay, well, center line is a 3. What else do I need to know? A vertical what?
Shrink.
Shrink. And what is that vertical shrink by a factor of? 1/2. What about the negative?
Reflection.
There's a reflection. Okay, and as always, that is a reflection across the x-axis. So if we pause for a moment, what a normal cotangent curve supposed to look like? A normal cotangent curve is supposed to be decreasing, correct? But what's the reflection going to make it do? The reflection is going to make it increasing, and so a reflected cotangent curve is going to look just like a tangent curve. Okay, let's see, what do I do next? Period. What did you guys get with period? Pi divided by b. What's b? Okay. And that invisible number in front of x is 1. So that b value is 1/2, right? We had one similar to this the other day. So pi divided by 1/2 becomes 2 pi. Are we okay if you know what you're doing there, right? Dividing by a fraction, we multiply by the reciprocal. And we have a phase shift of c over b, opposite the sign. So it's going to be positive pi over 4 divided by 1/2. What does this turn out to be? Pi over 2. Pi over 4 divided by 1/2 is pi over 4 times 2 over 1 becomes pi over 2. Okay, guys. Got all of our information here? So, with this one, a period is 2 pi. So every 2 pi, there's going to be a cotangent curve. If I'm requiring you to do not 1 cycle, but 2 cycles, that means minimum expectation, you're going to have to label up how far. If each cycle is 2 pi and I need 2 cycles, we're going to have to label up to 4 pi. Does that make sense? You're always going to label double what the period is. So if I'm labeling up to 4 pi, and going to do a similar thing what I've done in the past. There's 4 pi. The middle of 4 pi is 2 pi, 1 pi, 3 pi. You guys are okay with that? Yes? Now, we have to include the shift. What's my shift? Pi over 2. So that means right now we're on pi's, but we're going to have to include half pi's. So where do half pi's fall? They're in the middles, yes? We have 1/2 pi. In between 1 pi and 2 pi, we have 1.5 pi, which is 3 pi over 2. In between 2 and 3, we have 2.5 pi, which is 5 pi over 2. In between 3 and 4, we have 3.5 pi. 3.5 would be 7/2. Because I'm going right, I'm going to have 4.5 pi, which is 9 pi over 2. Could you just put tick marks on the halves? You could, as long as you've got your 1, 2, 3, 4 pi in there. Okay? Okay, we ready? This is officially what type of curve? Officially, this is a cotangent curve. What do we start with at the origin on cotangent curve? Cotangent starts with an asymptote on the y-axis, right? So before any shift, the idea would be there's an asymptote on the y-axis. But where does my shift take that asymptote? To the right, pi over 2. So my first asymptote is at pi over 2. Do you see why I don't put the original ones in on this one? It would get so crazy. I wouldn't know what were my original asymptotes and points and what were my shifted asymptotes and points. So now, there's an asymptote. I need an asymptote once every period. How long's my period? 2 pi. So I need to go 2 pi past 1/2 pi and put my next asymptote. What's 2 pi past 1/2 pi? And that puts me at 2.5 pi. I would go one more. What's 2 pi past 2.5 pi? And that would put me at 4.5 pi. Or if you're looking at the fact that periods every 2 pi, I have to the right of 0 is pi over 2. To the right of 2 pi is 5 pi over 2. And to the right of 4 pi is 9 pi over 2. So you can always just go to that period and go right one. Now, my points go where? Points are going to have to be in the middle, yes? And this is where, be smart. These are broken into 4 pieces, right? Where's the middle of pi over 2 and 5 pi over 2? 3 pi over 2. Where's the middle of 5 pi over 2 and 9 pi over 2? 7 pi over 2. Or basically I have 1.5 pi and 3.5 pi. Those are my points that I made really obnoxiously big. It's true. I don't know why I did, but I did. Okay. Cotangent normally says we are decreasing, but this is a reflected cotangent, so we're going to be increasing. So starting bottom left, increasing to the right. And are we stretching or flattening? We are flattening. So how I draw a flattened curve, hold on. I don't really like that one. Let me try this over here. Do you see the flatten I'm trying to indicate? That at the x-axis, when it's flattened, it is pulled closer. It runs more alongside the x-axis. Does that make sense? Whereas a stretch up here, I just cut through the x-axis and kept going. This flatten, I kind of got close to the x-axis, I didn't go horizontal, but I went very close to it for a bit before I went up. Okay, what questions can I answer there? Okay, moving on. Moving on. All these fun fractions. You guys love the fractions, right? Okay, let's see. What kind of center line do I have here? Did I label my center line on my last graph?
Yeah, I said it.
But did I label it on the graph? Backtrack.
Oh.
I'm so guilty. I told you I was guilty of this. On the first one, remember, as soon as we wrote center line down, I labeled it. Are you guys guilty like I am here? We didn't label our center line on the last graph. Sorry. Learn from my mistakes. Do better. Okay. So, what am I going to suggest we do? Center line is 1. What am I going to do? I'm going to get that 1 in there as quick as I can. Okay. Not amplitude. That's what my brain wants to say. Is it a vertical stretch or flatten? Don't all answer at once. Thank you. It's vertically flattening by a factor of 3/4. That 3/4 has a negative, so there is a reflection across the x-axis, if you will. Period. Pi divided by b. What is b this time? Okay, and what's the invisible number in front of x? There's a 1, right? Because we really need to know, it's 1/3 times x. And so this is going to be pi divided by 1/3, which is pi times 3/1, which is, interesting, 3 pi. This is going to be kind of like the weird one, kind of like working with thirds, but yet 3 pi is different. And we have a phase shift. C over B. So the opposite of negative is positive, so it's going to be pi over 2 divided by 1/3. Pi over 2 times 3/1, which is 3 pi over 2. Okay. Officially, this is a what? A tangent curve. Actually, hey, we need to label our x-axis first. I was all set. Do we start with a dot or an asymptote? Let's label our x-axis. Now, okay, our x-axis, a period of 3 pi. Which means if you double that, because we're going to need 2, we actually need to label to 6 pi. Okay. Now, as I label to 6 pi, keep in mind, 6 pi is the equivalence of 2 periods, yes? I'm not going to label 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. That's going to confuse me. This is 2 periods long. So when I break this into two periods, where's the breaking point between the two periods? What's the middle of 6 pi then? 3 pi. So right there, there's my two periods, yes? I'm going to need the halfway point of those periods. What's halfway between 0 and 3? My non-fraction brain is going to say 1.5. In between 0 and 3 is 1.5, which I just labeled as 3 halves. What's halfway in between 3 and 6? Again, my non-fraction brain is going to say in between 3 and 6 is going to be 4.5 is the middle. And 4.5 improperly is 9 pi over 2. Now, as crazy as this sounds, this is working for us, I promise. Because we have our periods of 3 pi, but then also, what is my phase shift? My phase shift is 3 pi over 2. And do I have 3 pi over 2 labeled? Yeah. Each of these marks I have is 1.5 pi, is the way it worked out. Okay? Now let me go back to my previous question. Cotangent or tangent? This is tangent. Does tangent say we start with a point or an asymptote? A point. So normally we would have a point at 0, 0. But where's my shift to tell me to take that point? Right to 3 pi over 2. I need a point once every period. My period is 3 pi. So where is 3 pi past 3 pi over 2? Are you with me on that one? So, and keep in mind, each of these marks was 1.5 pi, wasn't it? Or, okay, this is 1.5 pi past 0. My next mark would be 3 pi. 1.5 pi past that is 9.5 pi. And if you do it, 9 halves. 9 halves minus 3 halves is 6 halves, which is 3 pi. So my 2 points are 3 pi apart. If those points are my points, where do my asymptotes go? They're at the points on either side of those. So there actually ends up being an asymptote on the y-axis, an asymptote at 3 pi, and an asymptote at 6 pi. Okay? What curve am I drawing? A reflected tangent. So tangent is normally increasing, but we're reflecting, so it's going to be decreasing. Are we flattening or stretching? Flattening. So that means I'm going to try and run along the x-axis a little bit more than I normally would. Starting high, curving at the x-axis to flatten, and continuing down. Okay, are we getting there? Yes.
Before we start the next one, you have questions, so I don't have to.
It's like you're laying out right somewhere.
I can take one for Whitney too. So, because I'll probably see you.
If not, you can give it to her Monday. Okay, number 4. Do we have time for number 4? Yeah, we should have time for number 4. 3, cotangent 3x plus 2 pi minus 4. Well, let's see. What's my center? Center line is -4. Did you guys catch what I automatically did? I went ahead and labeled it, guys. I don't know. I know I always end up taking points off of some people because they forget to label that center line altogether. And it's not like you have the amplitude pieces that can save you because, oh, you labeled the top and bottom, I can figure out the middle. Like, no, if you forget to do it, there's nothing there to save you. Are you stretching or flattening this one? Yeah. Vertical stretch by a factor of 3 because my A value up front is 3. It's a positive 3, so no reflection. What about a period? Pi divided by b, so pi divided by 3. And what about a phase shift? Opposite the sign, so negative, c divided by b. -2 pi over 3. So we're working in thirds. In all honesty, it's not as hard to work in thirds this time as it is with sine and cosine, at least in my opinion. That's my opinion, though. Okay, my period is pi over 3, so I want to label in some thirds, correct? Label some thirds. Notice your shift goes left, so... Hello? Okay, I will let him know. Okay, bye. Your iPad has arrived. So.
Am I going to go get it now?
You can, or you can go get it after this problem. It's in the high school office, so
Okay.
Christy has it. Okay, guys. I just realized I labeled that -4, and that's actually, I'm going to end up having to move that, I think, just because I kind of am seeing what happens here. Period of pi over 3 means, okay, I need to label a third, correct? I can label 2 pi over 3, I can label 3 pi over 3, but what's the deal? Where's my shift taking me? It's taking me left, isn't it? So I'm actually going to go ahead, okay, there's pi over 3 on the right. I'm going to try and make an equal -pi over 3. And I'm actually, I guess I forgot about this, I'm going to extend my x-axis. And I'm going to make a -2 pi over 3, if you will. Because I know I have to go -2 pi over 3. Now, with that in mind, those are my periods. We need the midpoints because they'll either be points or asymptotes in the middle, right? So I'm just going to put tick marks. Officially, those tick marks represent my sixth. Now, what do we normally start with at the origin here? This is a what type of curve? I never talked about that. It's a cotangent. So cotangent starts with an asymptote. So normally there should be an asymptote at the axis, at the y-axis. My shift tells me to take that asymptote where? Left 2 pi over 3. So now I have an asymptote at -2 pi over 3. How often do I want to put every asymptote? Once every period. And what's my period? Pi over 3. So if I have an asymptote at -2 pi over 3, my next asymptote is going to be at -pi over 3. I want an asymptote at the y-axis, so it ends up being the same, doesn't it? And since I have it here, an asymptote at pi over 3. The middle of the asymptotes are going to be your points. So the ones that are officially your sixth are your points. And then think, which way are you drawing this? This is cotangent, which is decreasing. It's not reflected, so it's just a decreasing curve. with a stretch. So I'm going to start high, go low, and I'm not running alongside the x-axis. I am just crossing through the point. Does that make sense? Remember, minimum requirement is 2 periods. If, sometimes I've had 3, I've had 4, it just kind of depends. So, that's kind of where we're at. Give the worksheet a try for Monday. 2 cycles minimum. Got it? And I'll get you your worksheets.